Alright guys, so we're back and we're a little bit ahead on time. You guys can see it's early in the morning. Um, I took a little break after that, went and got some water. So let's get back into it. Now, we are done with the create network. So we have created the structure for this network, right? With this loop, we have everything we need for the structure that defines how the edges connect to each other and the placement of the input, hidden, and output nodes. But we do not, in our initial genome, we still do not have a way for hidden nodes to be created. We have input nodes and we have output nodes, but we didn't create the loop for hidden nodes, so let's just do that right here. Here you want to make sure that you put the loop for the hidden nodes after you put the loop for the output nodes, so that your hidden nodes will always be at the end of your list. So right here we'll do hid, which is the integer we get passed, and we'll just change the type to hidden right here. And that's it. Perfect. So this is how the code for the create initial genome looks. And this is done for the genome. This creates the starting genome for our networks. And then through mutation, this genome will be mutated and grow to be bigger and bigger. So basically, in the start of training, we create a genome. That genome, through training, each generation gets mutated, but the network gets created each generation. So the genome gets mutated each generation, the network then gets created off the genome each generation. Okay? And that is why we have these two separated. And that's why it's in the initialize right here. Both of them. Alright, so since the structure is now pretty much done, we're going to move on to the feed forward part of this. So this whole project is broken down into a couple of parts. The first part was getting the well, in Unity, the first part is getting the controller set up. Then we get the genome set up. Then we get the network set up, and so we get the structure of the network set up so that it's built off the genome. Now we're going to have it so where when we have a value for input, it gets fed forward into the output. So we are on the feed forward step now. And we have to create a way for our structure to feed information forward. And in our case, we're going to do it in an interesting way. So we're going to have for each node a loop where the value, so right now, each of our edges have weights. We're going to have a loop that stores the value of each node as well as the weight in the edges. Okay? So we take the value of 1 and we feed it forward into the edge right here and the edge right here. Then when it's time to when we get to node 5, when we get to the hidden nodes, we pull the information from the incoming nodes. Okay, this is a lot harder to explain and a lot easier to show in code. So I'm going to code it out, and then then I'll talk through the explanation of how it works, and hopefully people will be able to see it. If not, again, this is not a tutorial, it's a code along. I would love to make a very detailed tutorial where I write down a couple of things on like a one of those whiteboards or something, and one of those like virtual whiteboards or something, and I think that would be a good way to explain this. But in this format of just trying to code through this, it's a little bit more difficult. So hopefully you guys will see it as it's getting coded. But again, the general idea is that the value of the input nodes get pushed forward into the edges, and then the hidden nodes and the output nodes pull the values of their incoming edges. Okay, you by multiplying the value that is stored in the edge by the weight of that edge, and that simulates the neural network feed forward loop. So to start off with this section, since we're done with the create network, right? We're moving back down to the connection class, and we're going to add a variable. Since I said that in the connection, in the connections, in the edges, we're going to also store input value. So we're also going to store the value of the input node. Going back here, the input node for this edge is 1, so we're going to store in the edge the value of 1. So this should actually be input node value, and that way we get better name. Longer but better, I guess. Alright, so that will be good for that. Next, we have to create the feed forward loop, the feed forward function in the node, and we also have to create the set hidden node value and set output node value functions. All right. And so to start off, I think it's better to start off with the feed forward. So we're going to start off with public void feed forward, because that is one of a step that is going to be done on every node, while some of the other functions are going to be done on nodes that are hidden nodes or output nodes. Feed forward value. Okay, for each connection in connection con and out connections, output connections, we'll do on dot input value equals value. Excuse me. Yep. All right. So for each node, we're going to go through all the output connections. So the connections on the top side, the connections, these are the output connections right here for 1. And we're going to store the value, the input node value, in these connections. And that's what that loop does right here for each. Okay, and now after that is done, we're going to create another function right above that one. And this function is going to be the feed forward function. Well, it's going to be the function that sets the value for the hidden nodes. Okay, while in the feed forward loop. So this pushes forward the values. This gets the values from the this pushes forward the values into edges. These functions will get the values from the edges once they're written. And then there's going to be a feed forward loop in the neat network that manages between these 3 functions, which are going to be written. Okay, so we're going to come back down to this public void. Sorry, I know I scroll up and down a lot in the middle of writing code, but it's better for you to see the thought process and exactly what code I'm referring to. I don't want you guys to like suddenly get confused and I don't want you guys to just follow along and write down the code. I want you guys to understand, so you don't suddenly get confused in the middle of this. You know what I mean? And if you do suddenly get confused and get lost, you can navigate the code and find your way again, you know. All right, so we're going to do a set hidden values, hidden node value, and we're going to do public void set input node value and public void set output node value. So those are going to be the three functions for the input, output, and hidden nodes. And this is the feed forward loop for the edges, so that it's easier to refer to nodes. It's easier to refer to the node's value if it's stored in the edge compared to if it's just stored in the node. Alright, so now we're going to start with an input, which it's basically the start of our network, right? It's the first layer, and you can see the first layer gets information from the sensors. So in our example, the car has raycast, and the first layer will get information from those raycasts, the distances. But so since that's the case, we start off by getting float value. We're gonna call it float val, right? And then we have to set that value for the input connection. However, there's a problem with that. Usually in neural networks, we have activation functions to regulate data and make sure data stays between a certain range. And doing that with the input information will make sure that the input stays between 1 and -1. That function that we use is going to be sigmoid. Okay, so let me Google sigmoid, show you guys the function. This is the sigmoid function right here. So sigmoid start, it goes from -4 to 4, but it keeps data within this regulated curve right here. So for input, we're going to be using sigmoid, but for the hidden nodes, we're going to be using another activation function, and that is the reason why we have three different functions. Each of the nodes are going to be given might be treated a little differently, and so we create three different functions for each node. Alright, so for the hidden values, we actually use tanh. So let's go to tanh. Which it's right here. And all this is saying is that whenever you give a value, is going to be regulated between these, because they get forever closer to infinity as they get on either end. So even if you give a really big number, it gets regulated to this in this range. I'm just looking at different functions for my own curiosity. I want to see the two graphs side by side. So sigmoid stays positive, Sigmoid regulates between 0 and 1, and tanh between -1 and 1. Okay, my bad about that. That makes sense. And for the input, we are between 0 and 1, because our sensor data is never going to be negative, right? A distance is we don't ever have a negative distance. We just have a distance from the point. So we use sigmoid because it goes between 0 and 1, so it's never negative. And then even if we give it a negative value, it will regulate it between 0 and 1. And then a tanh is the one that goes from -1 and to 1, which is why it's used for our hidden nodes and for our input nodes. For our output nodes, not input nodes, for our output nodes. All right. It was a good thing I continued to look at these pictures. So right now we have the set input node right here, but we have to create the function for sigmoid. All right. So we're going to add a function line here, activation functions, and then we're going to do a private void sigmoid. And for this, we're going to take an x. So we're going to take a float x, and then we're going to give a y, right? And our y for sigmoid is 1 divided by 1 plus the exponent e raised to negative x. No, let me make sure what the function is. Yeah, e raised to negative x. Yep. So in C, we're going to C sharp. We're going to do math dot mathf float. I believe I have to I don't know if I have to input a library or something. We'll find out. So I'm going to save. It went all the way down because I saved. Wait, what the heck just happened? No. Okay, right here. Okay. Yeah, I just saved right there, so it broke off. But here it is. And now we're going to go to Unity, see if there's any errors. There are. Returns void. Ah. Okay. That's silly. Because it's supposed to return a float. So, it takes an x, returns a y, returns the float. So now that our sigmoid function is done right there, let me make sure that it matches reference. Yep, perfect. So now that our sigmoid function is done, we can simply, before we set value, we make val equal sigmoid val. Alright, so the value gets transformed into sigmoid of value, so it gets regulated. And then we set the value of the node to the regulated value we get from the input. I hope that makes sense. I hope you guys are keeping up. I apologize if this is confusing, but I appreciate you guys hanging in there. Okay, now we're going to do it for the well, let's finish some more let's finish the tanh activation function, and then we'll do the output and hidden node setting. So just like another function, we're going to do private float, and then this is going to be tanh. And for this, we're going to do float and it takes an x. Return the tanh function. I'm just going to go look at my reference for this because I don't want to keep searching on Google. So we're gonna go all right, I'm just gonna search it up. This is a good picture right here. Tan H. All right. Okay, got it. So it is this function right here, which is 2 divided by 1 plus e raised to negative 2x minus 1. So we're going to have two parentheses, and then inside the inside parenthesis, we're going to go do divided by another parenthesis, 1 plus mathf dot exp minus 2 times x, and then we're going to go to right here, which is the right before the last parenthesis. We're going to do minus 1, and that should be our tan h function right there. Let me make sure with my reference code everything is looking nice. Just adding some cleanup spaces. Alright, that looks perfect, guys. Next we're also, so we have our sigmoid and tan h, but we're also going to be doing a modified tan h. I'm just literally writing the above function over again, which I didn't have to do. I could have just copied it. But now that I have the original function written, we are simply going to change the 2 to a 4. And that is our modified function. And on Desmos, I will show you guys what that function looks like, but I just don't feel like keep on Googling and pulling up Google and testing my luck. Alright, so now that we have our activation functions, we can move into our set output node value and set hidden node value functions. We should, however, cut this right here and paste that right above. So we have input node, hidden node, and then output node, because that's the order in which the loop will run. Alright, so for our set hidden value, we simply set the float and we loop through. So we create a float for 0. We just hold a placeholder float for now, which will be the addition of all the previous edges. And then once we add to this value, then we will set that as the value for this the hidden node. So by that I mean we look at all for, let's say, the output nodes, because the output node and the hidden node will be similar. So for the output node, we look at all these previous edges, and the value that equals 0 has to be the addition of these edges weights times the value of the nodes they are connected to. And these edges each store the information, the value of the input node that they were connected to. So for the set output node function and the set hidden node value function, all we have to do is loop through the these connections and then multiply the value that is stored in these connections by their weights, and then add that to the value of the node right here. So basically, this is representing the function that is the neural network. You know what I mean? For each node, the function that represents the node is in this step, the set hidden node value function step. So right here we do this, then we do a for each connection on in connections, start incoming connection, and then we do val plus equals. We want to add for each, keep adding the value to the 0. This is going to be con dot, let's make this a parentheses, con dot weight times con dot input node value. Beautiful. And now that that's done, we can do value is equal to the tan h of val. So after we add everything, we pass it through our regulation function and then give it into store it for the next loop. Okay. And now we are going to do the set, the same thing for the output nodes. However, for the output nodes, I have no activation function on the output nodes. I just leave it. In this case, I am not going to just leave it. I will have the activation function. So I'll leave the tan h activation function. So everything will look the same. But in my reference code, I don't have a tan h. So we'll see how that works when we're actually looking at the fish moving. So now that our set hidden node value and set output node values are done, we're pretty much done with this part. There is a mistake in here, however, because whenever we are not resetting our value for the next step yet. After every feed forward, we have to reset all the values that are being stored. And for that, we will do that in the feed forward function that is going to be in the neat network, not the one that is present in the node class. All right. So we're done with the node. We have the set input node values, set hidden node. We have everything done for the node. Now we will do the function for the feed forward. That's not going to pick anything. Yep. And yeah. Actually, it is going to give the outputs, right? So it will give a float array of floats, and it will take the inputs. So an array of inputs, right? So our feed forward network function will be called in each update function for the NeuroEvolution in the NeuroEvolution controller. So anytime the NeuroEvolution has to evaluate where it needs to go after moving, it will call feed forward network, and the outputs will tell it where to move. Next update, it will move, and then it will have to reevaluate where to go. And in this manner, it will slowly get closer and closer to food. All right. I need some water. Hold up, guys. Bear with me. Better. All right. So since we have to create a float for outputs, we're going to create a float, and we're going to call it outputs equals new float, and we're going to make it of the length of the input node, because our outputs are basically whatever value is stored in our output nodes in each activation. So like before the activation, like right now at this moment in code, all the values are 0, or they don't even really exist. But yeah, all the values are 0, and then in the after this function, we get a value which we then return, and then we have to zero out everything again. After before returning it, we zero everything and then return. So output is going to be the length of the output nodes dot at count. Okay. And then we do our loop for the feed forward. So we're gonna go through all the input nodes first. Right, so we do the set value, input nodes, inputs, and we're gonna pass it the input we're on. So our inputs are for the sensors, right? So let's say our fish has 3 sensors that tell us its directions. That means we need to have 3 input nodes. The 3 sensors are right here, and their length has to match the length of the input right here, which is inputs.count. Or you'll have sensors that aren't giving any value to the network. Okay, so we pass it the inputs, and now that we have values in our input nodes, we then feed those values forward to the edges. So this function right here is the function that feeds the values forward to edges. Alright, so that takes care of the input nodes. And now the values are in the edges, we can use the hidden nodes to set the hidden node values. Now we go through all the hidden nodes. And here we go hidden nodes. Hidden nodes I dot set hidden nodes value, and this doesn't take anything. And now that all the hidden node values have been set, which means that the loop has went through the hidden node and pulled the previous value. Okay, well, we're gonna loop through the hidden nodes. In each loop, on each hidden node, we're going to first set the hidden node value, which pulls all the previous nodes value, and then we're going to do hidden nodes feed forward to the edges so that the next edges have their values prepared. And that way, if we have like future hidden nodes that connect to old hidden nodes, information will still properly pass on through them. Alright. And now we are going to do the same thing for our output. The main thing about the output, however, is that outputs do not feed forward value. Feed forward values are only done for the input and the hidden nodes, because outputs don't have anything to feed anything forward to. I know I said before that the feed forward function is going to be used by input, output, and hidden. I apologize, I misspoke. So we're going to follow the same pattern where we do set, but this time we do set output node value. So now we have our output node value set. Since and while we're looping through each output node, when we get the value set, we have to then get our return object ready, our list of floats. So outputs I, which is our list of floats, then gets the value. Alright, so that's basically our function. And then at the end, we do return outputs, right? But we still need to over here add, after all our loops are done, we should reset our value because our value is already been stored in the edge that it has to then feed forward to. Okay, so after our input node value is set and the feed forward is done, there's no real reason for our input node value to stay that, and it actually should be reset to 0. And so right here we will do input nodes I value equals 0. And then at the end of this, we'll do the same thing here. Because we have to set the hidden node value, so that's why we run this function. Right after the hidden node value is set, we run the feed forward value function, which stores the hidden node's value in the edges, so that then we no longer need to use the hidden node value, right? So let's change that to hidden nodes, and let's do the same thing for output. Because once the output object has received the output, there's no reason for the output node to still contain the value, and should be reset so that in the next loop there's no addition problems and it just gets reset. Feed forward happens normally. So yes, after that is done, we can return outputs, and that is the end of our feed forward network. So basically, now we should have everything we need to have this neural network working. We have the feed forward network done, we have the structure done, we have the genome done. Okay? All we really need is to get this feed forward network connected to our fish controller. So let's figure out how to do that next. Alright. Before I end this recording, because I do want to stop this recording to start the next one, because this is the end of our network section of creating the structure and creating the feed forward, I want to make sure there's no errors in this code. which I'm sure there are. Yep. Probably input connections, yes. So in the hidden value, in the output value, where it says in connections, that should be input connections. Okay. So it looks like I'm trying to access value on a list somewhere. The place where I would be accessing value is in our feed forward loop. Right here. Let's see, if I comment this out, will the error go away? Nope, so that wasn't it. I'll leave those back in. I have to see everywhere where value is being called. There's value written everywhere. It's going to be input nodes. Good. So input nodes I dot value, and that should be good for that. Apologies, I hope you guys see the errors that I made. One of the errors was that I did not have the index right here. So that it was trying to actually access the value of list, but list doesn't have a value. So we have to give it the index, so the specific object within the list. Okay, and then also there were also right here where it says in connections, I had in connections, and it should be input connections. Okay, guys. So now let's go back and see if those errors are basically done or if we have more. And that's good. That's everything. Our network is done. Now let's start getting it ready to be connected to the fish.